Here we have an EVGA 3090 video card that came in for repair. And this is one of the video cards that we get in on daily basis, just like Asus laptops, Minimax tuners, and those devices that we see every single day. Mercedes-Benz key fobs is one of the devices that we get in every day. A common failing point on EVGA 3090 usually is a short circuit on the 12 volt line. We have three 12 volt lines, 1, 2, and 3. We have a coil here, a coil here for one of the 12 volt lines. We have another one here, and we have another one here. The first thing we do on this card is we measure for a short circuit to see if we have a short circuit on any one of the 12 volt lines. Then we can measure 12 volts on the PCIe connector down on the bottom. We measure 3.3 volts also down at the connector. A common failing point on those cards is also the back here where we check for this fuse. I have more than a couple of videos showing that that fuse was blown on back of the board along with other issues with the card. I've done a lot of videos about the EVGA 3090. Now these cards, they fail suddenly and they display a red LED light on the card, and it's a very common problem. Let's read what the customer wrote. The customer said, "I heard a noise coming from a video card. After noise, I heard some click and the red light appeared on the video card. It felt like something small blew inside of it." I mean, it has to be something small because there's nothing big on the card, except maybe if you want to consider the capacitors to be big. Yes, they are bigger than other components on the board, but those caps, the aluminum caps, they almost always never fail, especially on those cards. We're gonna jump over to the card and we're gonna test to see if we have a short circuit. And I'm almost 90% positive that we're gonna have a short circuit on one of the 12 volt lines. That's a signature fault with those cards. We're gonna start at the top here. We can measure at the fuse, we can measure at the current sense resistor, or we can measure at the coil. And we have a short. You should never have a short on a fuse. We have a short circuit. A 0.01 voltage drop short circuit. If we measure coil number 2, we are reading normal 0.49 voltage drop, and if we measure coil number 3, which is responsible for the third voltage input, and we are reading 0.48. So we have a short circuit here. We can quickly jump over to back of the board, measure the fuse, make sure it's good. And we can also inspect the PCIe 12 volt line, 3.3 volt lines. If all good, then we can proceed with the repair. Okay, so the fuse is good. And to measure the PCIe 12 volt line, we measure at the third pin or any one of the 3 pins here. This, or this. 0.51 voltage drop, and we measure the 3.3 volt line, and we have a good reading. 0.6 voltage drop. While at it, we can also check our 1.8 volt line. It should read something around 227 ohms, 229 ohms. A very low reading is likely a GPU core issue. So let's say I'm reading a short circuit here. There's no reason why we would continue working on the card. It would be a core related issue. Or maybe we are reading a very low ohm reading here. Maybe 20, 30, 40, even 100 is low. So if we measure in ohms mode, what do we have? We are getting 229 ohms. Exactly 229. So we know our core is likely good. 1.8 is reading proper. And we can also check our PEX line. It should read anywhere between, let's say, 3 to 9. 3 would be on the lower end. I would be a bit worried, but I've seen it. Right now we have a reading of 9, exactly 9 ohms or 9.1 ohms. So there's a very good chance that our core is still good. All readings are proper. And all we need to do is The fastest way to do this is to inject voltage at the short circuit on top here, and we're gonna monitor the board under a thermal camera and see what gets hot. And based on my experience working on those cards, it's almost always one of those DR MOSFETs that you see here. Usually DR MOSFET number 4 or 5 or both. Right now, if you look at the DR MOSFETs here, they are labeled A100. It's a common DR MOSFET on EVGA 3090, 3080, but we use a replacement by NCP. So if we do use a replacement, it's best to replace both DR MOSFETs that are connected in parallel, so we have exactly the same chips for that phase. So if we find out that we have a problem with this, then we also take the one next to it. Each two, starting from the top, that's 1, 2. Those are connected in parallel. Those are connected in parallel. Parallel, parallel, until you reach the end, and that's where memory is. Let me check memory quick. And we have a reading of 50 ohms. Perfect. If we check here, we're gonna have a very low resistance. Okay, we have a 1 ohm reading, and all of them are gonna have low resistance because they are connected directly with the GPU. Voltage injection tool on, and have that short. If you do not already have one, log into our website, NorthridgeFix.com, click on shop, add to cart, along with all the tools that we use. Everything that we sell on our site is what we use on our bench for the most part. Whatever you are buying off our site are good tools that you can use professionally. I went through this in a lot of videos explaining how we vet or how we go about choosing our products, testing our products, comparing, and all that good stuff. You can look at the video I posted maybe a week or 2 weeks ago, our products, and it contains a lot of information. Right now, let's inject voltage at the short. And let me grab the thermal camera quick. Okay, so our DR MOSFETs are right here. So we want to look at this line, specifically this line. We have a lot of DR MOSFETs. Okay, so I'm injecting voltage, and I can already see where the problem is. If you look at this line of DR MOSFETs, and you look all the way on top, I see it right here. A very slight heat spot, but it's right here on top. And it's amazing that it's the first one on top. Usually it's the 4th or 5th one. If you look at a lot of the videos I did on EVGA 3090 or 3080, it's never the top one, or it's very rare for it to be the top one. But the first DR MOSFET on top is what's getting hot. Okay, so it's this one right here. So let's go ahead and replace both. Like I said, if I want to replace AL00 with NCP, I want both of them to be the same chip. I do not want to mix and match. That's one reason. This DR MOSFET may very well be fine, no problem. But since I'm going to use a different chip, a compatible chip, then I want them both to be the same. Now we have aluminum capacitors here, and you know how aluminum capacitors are like. If you apply hot air, they're gonna pop in your face. You're gonna lose an eye or two, and that almost happened to me in previous videos. So this one here is safe to work on. We do not have any aluminum capacitors, but if I wanna apply heat here, I would feel safe if I remove this cap. Better safe than sorry. I could cover it. I could put a shield that covers this side from that side, but it only takes me a minute to remove it. So the safest way would be to remove this cap, and then I have a lot of room to work here. So without wasting any time, let's do it. Flip the board. We're gonna start by desoldering the aluminum cap, and it's the first one on top. Right here. How do we desolder it? You already know the magic of low melt solder. Apply NF.flux. Fume extractor on. And the fume extractor is important, very important. Okay, so I push down on the cap, and the cap should already be out. Okay, right there. The cap is out. We're gonna put it on the side, and let's clean the holes while at it. Very nice. Now we're gonna proceed to desolder both the arm MOSFETs. Now we're gonna put back the cap, solder it, and then we can test. And we are done. We soldered two new DR MOSFETs on top here, the first and the second one. And we also soldered this capacitor here. And amazing. All we have to do is test, or before we test, we need to check if we still have a short circuit. I've done it late in this repair, but let's do it. Now, I would be extremely shocked if we still have a short circuit. What are the chances? 1 in a million. Do we still have a short circuit? Meter in diode mode. All right, awesome. We are reading 0.46, and that's amazing. If we check here, 0.46, and if we check here, same exact reading, 0.46. We did an amazing job. Very happy with the results, and like always, better than factory. We never had a card that came back after replacing the AL00 with the NCP chips. All we have to do is test it. Big Boss is not in today, so we're not going to be able to reassemble and do a full benchmark on it, but he's going to test it tomorrow. For now, I just want to see an image. And we're going to call it a fix if we see an image. We already released or fixed the short circuit, and now I just want the card to turn on and show an image. And I'm gonna put this tiny heatsink on the board for the time being, and we're gonna look at this monitor. And of course we need our 12-volt inputs, 1, 2, and 3. I connected the PCIe adapter, which is connecting to a Dell motherboard. So when we power the card on, we're gonna see a Dell logo and we're gonna see text. Press F1 to continue. And that way we know the card is working. Make sure the cables are in. HDMI cable plugged in, and let's do it. The card is on. Okay, so we have 6 beeps. We have 6 beeps. And I know why. We have 6 beeps, and I know why. We forgot to do one thing. I rushed into testing the card, and there's one more thing we need to do, and I'll show you what. I was surprised I got 6 beeps because that's not expected, but I forgot to do one thing. And it's a good thing I forgot to do it, so you know what that thing is. Let's go under the microscope. Now, I told you how we measured for a short here, and now we do not have a short anymore. Let's go ahead and measure. Meter in diode mode. And we are reading 0.465, and that's amazing. But one other thing we need to do is anytime there's a short circuit on this line or any one of the 12-volt lines, the fuse will also blow along with it. So if we measure the continuity of the fuse from here to here, it's blown. We're gonna get a diode reading if we measure here, but not here. We have a blown fuse. And that's one of the things that we have to do anytime we replace shorted DR MOSFETs. We also have to replace the fuse, and that's what I forgot to do. I have this done in every one of our videos working on EVGA 3090s, but I rushed to test the card without replacing this fuse. No problem. Let the adrenaline kick in. More suspense, right? How many of you were disappointed? Amazing. Look at how nice the joints are when you have good flux. Now we're gonna grab a fuse from this strip of fuses, and you can see how many I used. Because EVGA 3090 or 3080 is one of the cards that we work on every single day. Beautiful. Now we can test. Now, if the card still does not work, then we can break it in half. The customer is okay with it. I hope the customer is not watching. Okay, so we have 3 12-volt inputs, PCIe, and we have our HDMI cable. And our tiny heatsink right here. And we're gonna turn the card on. All right, the card is on. And yes, Dell logo, and amazing. Wow, amazing. The card is fixed. Let me just turn the power supply off. Big Boss can reassemble and test it tomorrow. Invoice and mail it back to the customer. We are done. I hope you enjoyed the video. Let me know what you think. Leave it down in the comments. Don't forget to like and subscribe, and we'll do something else in the next video. Amazing.